Greetings, chemistry students. Let's present us yet again. We're talking about Hess's law. We're in chapter 12 of the textbook. I strongly suggest you look in the textbook and give the author a try. I think that might be helpful. But in addition to reading the book, let me give you some brief overview of Hess's law. Now, we're looking for delta H, and what Hess said was that delta H can be found indirectly. All right, and so we're going to find delta H indirectly using the H values for any set of reactions that yield the desired reaction. So H can be found indirectly using the delta H values for a set, more than one, of reactions that yield the desired reaction. All right, that's the textbook definition, and let me see if I can put that in layman's terms. What we're going to do is we don't know the delta H for this reaction, but we do know the delta H for these three reactions. The delta H is over here in this column. So if the sum of these three reactions is the same as our desired reaction, then we could add these delta H's and come up with the delta H of our desired reaction. However, in so doing, we very well might change these delta H's. So that's what we have to pay attention to. So let's get cracking. First one. The problem here is that on the product side, we don't have our desired product, do we? We don't have our desired product here. So consequently, we're going to have to flip a reaction. Here is our desired product. So we're going to have to reverse this reaction. That's easy enough. To reverse the reaction, all we're going to do is rewrite it to CO2 plus 3H2O. Those were the products, and I'm just going to flip it around, and C2H6 plus 7/2 O2. Now, in so flipping, I no longer have a negative, but because it's the reverse reaction, I've got a positive. So that's the bit that you have to pay attention to. We're no longer using this reaction. Okay? So so now what we could do is take a look and see if we could cancel those reactants and products that are doubled up and get our desired reaction. All right? So if we take 1/2 away from 7/2, so all we're going to do is we're going to cancel 1/2 from 7/2. So 7/2 minus 1/2, that's going to give us 7/2 minus 1/2 is going to give us 3O2. Well, that's convenient because we have 3O2s here and we have 3O2s here. And remember, you can only cancel if it's the opposite side of the equation. And we don't have O2 in our desired reaction, so the O2s went away nicely. Right? Now, we want this in our reactant side. We want this in our reactant side. Right? Now, the CO2s we don't want. The CO2s we don't want, because we don't want CO2, and we just so happen to have a CO2 on this side, and we happen to have a CO2 on this side. Right? So we cancel the CO2s because they're on the opposite sides of the equation, just like in algebra. and we have two H2Os here, we have one H2O here for a total of 3. We have 3 on this side. Lovely. They all go away, and now let's just find out what's left over. C2H4, that's left over. That's left over. Anything else left over? Lovely. C2H6. Does that resemble what we started with? It does. What changes have we made over here? We didn't multiply by anything. All we did was we just changed this sign, didn't we? So changing that sign, you add these up. Make sure you put parentheses around these whenever you put them in your calculator. Make sure you add, not multiply, and you should get negative 137. Those are kilojoules. Units are important. Okay, so that's our delta H. Nice. It looks a bit of a mess. Let's try another one. That's because we're canceling so many things out. All right. Here's another one. We want to find delta H of this reaction. We're going to use these 3 reactions. Here's our delta H's, and they're all in kilojoules. All right. So instead of me writing delta H, and I didn't need to write positive, but those are the now. Let's take a look and see what we have in our reactant side and what we have in our product side. Now, notice that for this one, we're going to need to move this to the reactant side, aren't we? If you think about the big molecules first, the small ones seem to take care of themselves. The individual molecules seem to take care of themselves. The larger ones are the ones that are usually the pain. So obviously we have to reverse this. So C2H4, 2C plus 2H2. All I did was reverse it, and when I reversed it, I'm going to have to change the sign, right? Okay, so I'm going to need. I definitely needed to reverse that. We also need this in the product side, don't we? So I'm going to need to reverse this one. C plus 2F2 equals CF4. And so reversing, I'm going to need to do the opposite sign. So now I have this on the right side, but I don't have enough of them. So chances are I'm going to have to multiply by 2, this whole thing, aren't I? This I have on the right side. F2 is on the right side. To F4, CF4 is on the right side. 4HF is on the right side. So now that we have everything on the right side of the equation, so to speak, the reactants are on the right side and the products are on the right side. Now we just have a bit of a problem with regard to the number of them, right? So we're going to need to multiply. We need 4 of these. So what I think I'm going to do is just multiply each one of these by 2. So just put a 2 in front of each. So this turns into a 4, and then multiply this by 2. All right, and then that makes this 4. So all I did was double it. I just doubled the recipe. Right? That's simple enough. Just double the recipe. Now this down here, as you can see, we need to double this recipe too. So let's double this recipe as well. This time makes a 4, and this makes a 2. But remember, we're going to have to multiply this by 2 as well. All right. Now let's see how it falls apart for us. So the 2, we don't even need hydrogens. So these go away for us nicely. Let's see, F2, plus 2, so that gives us 4. That's good. The 2 C's, we don't need those, right? So let's see how this shapes up. We have the C2H4. We have the 2 plus 4 makes 6F2. All I did was add these two together. And we have the 2 CF4s from here, right? And then we just bring this down, 4HF. So we multiply. We have to basically make sure you enter it into your calculator. 2 times negative 530. That's a 3. 7 plus a negative 52 plus 2 times a negative 680. All right. So make sure you put it in your calculator exactly like that, or else you might have a problem. All right. So bear with me for just a minute while I so I got a negative 2,480, 680. And those are in kilojoules, of course, and that's our delta H. All right. All right. Let's see if we have time to squeeze in one more. This is we don't know the delta H. It's another Hess's law. Here's our equation. We're going to try and make that equation from these 3 equations. So we're going to use these 3 to try and make this one equation. All right. So in our product side, we need the H's in the product side, so we're going to need to reverse this, aren't we? So 2NH3 N2 plus 3H2, and that changes that number. That changes that sign, doesn't it? And we get rid of that. So now we have the H's on the right side. Now if we multiply that by a half, if we multiply all this by a half, we could get rid of that 2. Let's hold on to that for a second. But let's see, here we need this on the other side too. So this is another reverse, isn't it? CH4 C plus 2H2. Don't forget that. That's another reverse because we need that on that side. And what else? It looks like this can stay, right? This can stay, but we can get rid of these 2s. We can get rid of this 2 by multiplying by a half. So if I multiply each by a half, this just becomes 1, right? That becomes 1. And this becomes a half, and this becomes, when you multiply 2 by a half, it becomes 1. So this is just, we're back to 1 or nothing there, right? So this is 1 or nothing. I shouldn't say nothing, but there's no when there's 1, you typically don't put a coefficient. So that's what I mean by nothing. That's very confusing. I don't mean to do that. Okay, so let's go back up here and do the same thing. We need to multiply this by a half. So when we do that, we just lose this because that becomes 1, and this is 1/2, and this is 3/2 then, right? All right. So we multiplied this by a half. So don't forget to do that. We change that sign, and don't forget to multiply this by 1/2. Can't forget that. All right. So let's see how it cancels out for us, and see if we can get our equation. All right, so this is fine. What don't we need here? We don't need this. We don't need this 1/2. We don't need this 1/2 nitrogen, do we? So, where's the other 1/2 nitrogen here? It's right here. And let's see. We need 3 of these, so 2 plus 2/3. It becomes such a mess, doesn't it? So 1/2. Oh, this is fun. 1/2. So 3 halves minus 1/2 is 1, isn't it? So if we could turn this into 1 and cancel this one out, which is convenient. All right, so we have, let's see what we've got so far. HCN comes down very nicely for us, and 1 plus these, that makes 3, so we have 3H2 very nicely for us, and the carbon goes away for us, and the CH4 nicely comes down, and the NH3 comes down for us, and H3. So we have to add these up. So put it in your calculator. 1/2 times 91.8 plus 74.9 plus 1/2 times 270.3, and that should get your delta H. All right.